Hi everybody, so we're going to do a short little set of notes here on Newton's laws of motion, which really should be review. First law, an object at rest will remain at rest, an object in motion will stay in motion. That's typically how you have it, but look here, an object at rest will remain at rest, and an object in motion in a straight line. It's a really important part of this. Will stay in motion unless acted on by some kind of unbalanced force. Excuse me, if you are driving along in your car and you go ahead and take a quick turn, your body moves to one side or the other depending on which way you turn because it's trying to stay in that straight line. It also gets the nickname of the inertia law. So the examples we're actually going to fill in during class. All right, second law. An object that is acted on by an unbalanced force will accelerate in the direction of the unbalanced force. And you will see we have a formula, F net equals ma. Force is in newtons. You can keep in thinking that is like pounds in the English system. Mass is in kilograms, and acceleration is generally meters per second squared, although we're going to see there's a slightly different unit soon. Okay, so our example, we're going to fill in during class. So we're going to do, anytime there's a formula, we always do a practice. So an object with a mass, so this is your m, is acted on by a net force, so this is the force, and the question mark is the acceleration. So F net equals ma. So we have 250, I'm throwing the units in for a reason. I know we don't usually do that. Equals 15 kilograms times a. So you're going to divide both sides by 15 kilograms, technically. And when you take 250 divided by 15, you're going to get 16 repeater. So a equals 16.67. And if you look at it directly, the units are newtons per kilogram. And we don't use that a lot, but they're equivalent to meters per second squared. So it's just, there's two possible units you can actually use for acceleration. All right, Newton's third law. Let's go to the other page. For every action, there is an equal and opposite reaction. I know you have all heard this one. There's no formula with it. Again, we're going to add some examples. So mass and weight are included here because they are a special relationship to F equals mg. So weight, and usually we say Fw. Weight is the force due to gravity's pulling on you. So it's still an F equals ma, so technically g is an acceleration, it's just always going to be negative 9.8. So one of the things we can do is convert your weight into newtons from pounds. So first of all, this formula is wrong. It's pounds divided by 2.2. So let's, and you should put in your own number and try it, but I'm just going to say, what if you weighed 150 pounds? How much newtons would that be? Well, let's see. So I took 150 divided by 2.21. A lot of times we just use 2.2. All right, so that's 67.87, 67.87. And then we times that by 9.8. And that comes out to 665.16 newtons. So you see the difference between pounds and newtons. I don't like weighing in newtons. All right, so these two pictures here are to show you specifically what happens. Let's say both of these objects have a mass of 1 kilogram. If I'm looking strictly at the force due to gravity, that means that the acceleration equals g, which is negative 9.8 meters per second squared. It's our traditional unit. Here, if I'm pulling it, I would have to know, for example, what I'm pulling it with, what kind of acceleration. So let's just say I'm using 2 meters per second squared. What would the forces be? In this case, we call it F net, and in this case, we're going to call it Fw. So in this case, it's 1 times negative 9.8, which is negative 9.8 newtons, which you could convert to pounds if you wanted to go backwards. And here it'd be 1 times 2, which would simply be 2 newtons. So direction has a big impact on what's going on with forces. All right, so we're going to do some videos and get some examples from these, and then we'll be doing some practice with these particular formulas. All right, thanks everybody.